From a distance, HD 189733b looks like it could be another Earth. It's a deep blue color and orbits a star about 64 light-years away. But that blue color is not because of oceans or skies. It comes from tiny glass particles in its atmosphere. And that same atmosphere is one of the most violent ever discovered. HD 189733b is what scientists call a hot Jupiter. It's a gas giant much bigger than Earth, and it orbits extremely close to its star. A year there lasts just over 2 Earth days. Being that close to a star means the planet is incredibly hot. Temperatures reach nearly 1,700 degrees Fahrenheit. That heat drives winds that reach speeds of more than 5,000 miles per hour. These winds don't just move air around. They carry tiny pieces of glass, and those pieces fall from the sky like rain. Because of the high winds, it doesn't fall straight down. It blows sideways like glass in a sandblaster. This makes HD 189733b one of the most dangerous weather systems ever found. Unlike Earth, this planet probably doesn't have a solid surface. It's likely made of thick, swirling gas all the way down. If we ever sent a probe there, it would be destroyed almost immediately by the pressure and storms. This planet is also special because it was one of the first exoplanets where scientists studied the atmosphere in detail. By watching how light from the star changes as the planet passes in front of it, scientists can tell what chemicals are in the air. This method is called transmission spectroscopy. What they found was shocking. They discovered high heat, strong winds, and the signature of glass-like materials in the air. And the blue color? That comes from the way light scatters off those tiny particles, kind of like the way Earth's sky looks blue because of sunlight scattering. HD 189733b may look peaceful from far away, but it's actually one of the most extreme places we've ever seen. It's a perfect example of how strange other worlds can be, even when they seem familiar at first glance. Kepler 438b is a rocky planet that orbits a red dwarf star about 470 light-years from Earth. It's almost the same size as Earth, and it sits in the habitable zone. That fact alone made scientists very excited. Could this be a second Earth? At first, everything about Kepler 438b seemed promising. It has a radius just 12% larger than Earth's and receives only about 40% more energy from its star than we do from the Sun. Its surface temperature might be warm enough to support oceans, and if it has an atmosphere like Earth's, it could possibly support life. But there's a catch. The star it orbits is not like our Sun. It's a red dwarf, which means it's smaller, cooler, and much more active. These stars are known for producing strong solar flares, and Kepler 438b's star is no exception. In fact, it produces powerful flares that are likely blasting the planet with intense radiation. These flares can strip away a planet's atmosphere, especially if it doesn't have a strong magnetic field to protect it. That means even though Kepler 438b might sit in the right spot for life, it might not have the right conditions to keep life going. Without an atmosphere, there would be no surface pressure, no protection from space radiation, and no way to keep water from boiling away. It would be like standing on a rock under a heat lamp in the middle of space. Kepler 438b could be a second Earth or just another dead rock in space. Right now, it's still a mystery. But it shows how complicated the search for other Earth-like planets can be. Even if a planet is the right size and in the right place, that doesn't mean it's friendly to life. 55 Cancri E is a super-Earth located about 40 light-years away in the Cancer constellation. It's about twice the size of Earth and 8 times as massive. What makes this planet especially fascinating is what scientists think it might be made of. Based on its mass, density, and the types of stars nearby, some researchers believe 55 Cancri A could be rich in carbon. And under high pressure, carbon can form something incredible: diamond. The idea of a diamond planet sounds like science fiction, but it's based on real science. On Earth, diamonds form when carbon is squeezed under immense pressure deep underground. On 55 Cancri A, the pressure and temperature may be even more intense, strong enough to turn huge amounts of carbon into crystal. That means the planet's interior could be packed with diamond. Not just scattered deposits, but possibly entire layers or even a diamond core. That's not the only strange thing about this world. 55 Cancri I orbits very close to its star, so close that a year there lasts just 18 hours. Its surface temperature can soar to over 4,000 degrees Fahrenheit on the sun-facing side. It's so hot that rocks might melt into lava. Observations have shown changes in brightness, which could mean the planet has lava lakes or volcanic activity that shifts over time. Because it's so close to its star, 55 Cancri I is likely tidally locked. That means one side always faces the star and the other side is in constant darkness. The hot side gets blasted with heat while the cold side stays much cooler. This creates a strange environment with extreme differences between day and night. WASP 12b is a hot Jupiter, about 1,400 light-years away. It's a gas giant similar in size to Jupiter, but that's where the similarity ends. This planet is in a dangerously close orbit around its star. It's so close that it completes a full orbit in just over 1 Earth day. That tight orbit puts it in serious trouble. The star's gravity is pulling on WASP 12b's atmosphere. Gas is being stripped away and pulled into the star. In other words, the planet is being eaten. The material forms a kind of cloud around the star, and scientists can detect it by watching how the star's light changes as the planet moves around. WASP 12b is one of the darkest planets ever discovered. It reflects almost no light, making it blacker than coal. Scientists aren't sure why. It could be because the atmosphere is filled with light-absorbing chemicals, or because of the extreme heat. Temperatures on the planet reach up to 4,600 degrees Fahrenheit. As the atmosphere is pulled away, the planet gets more and more distorted. It's not round like most planets. It's stretched out into an egg shape by the gravity of its star. Over time, it may lose so much of its mass that it no longer exists at all. What makes WASP 12b so interesting is how it shows us the power of gravity in action. We're watching a planet disappear piece by piece. It also helps scientists understand what can happen to planets that orbit too close to their stars. In the distant future, even our own solar system could face changes like this. As the sun grows older, it will expand into a red giant. Planets like Mercury and Venus could be swallowed. WASP 12b gives us a glimpse of what that might look like. Gliese 581c was one of the first exoplanets to spark real excitement about the possibility of alien life. It's located about 20 light-years away and orbits a red dwarf star called Gliese 581. The planet is around 5 times more massive than Earth and sits near the edge of its star's habitable zone. That's the area where temperatures might allow liquid water to exist. At first, this made it seem like a great candidate for life, but things are not so simple. Gliese 581c orbits very close to its star, and red dwarfs can be unpredictable. They flare up often and blast nearby planets with harmful radiation. Also, the planet is likely tidally locked, meaning one side always faces the star while the other is stuck in permanent darkness. The side facing the star could be boiling hot, while the dark side might be freezing. Still, some scientists believe there could be a narrow region between the hot and cold sides where temperatures are just right. This area is called the terminator zone, and it's where light from the star fades into darkness. If the planet has a thick atmosphere, it might spread heat more evenly and keep this region stable. That could create a small band of habitability. Over the years, some studies questioned whether Gliese 581c even exists. The data used to find it was noisy, and some researchers thought it might be a false signal. But later analyses supported its existence. The mystery hasn't gone away, though. We still know very little about the planet's surface or atmosphere. If Gliese 581c has water, it probably wouldn't look anything like oceans on Earth. Instead, the planet might have a very dense, steamy atmosphere that could trap heat. This runaway greenhouse effect could cause surface temperatures to rise even higher, possibly boiling away any water over time. Alternatively, if conditions are slightly different, the atmosphere might instead shield the planet, making it more suitable for liquid water. Astronomers have also considered whether Gliese 581c could have moons. Large moons might stabilize a planet's rotation and climate, possibly improving conditions for life. If moons exist around Gliese 581c, they could offer stable environments protected from the harsh radiation of the host star, making them intriguing targets for future exploration. The truth about Gliese 581c remains hidden behind unanswered questions. Telescopes and new missions may eventually give us clearer answers, but for now, scientists continue to debate and investigate the possibilities this mysterious world holds. HD 106906b is one of the strangest exoplanets ever discovered. It's massive, young, and drifting far away from its parent star. Located about 336 light-years away, this planet is 11 times the mass of Jupiter. But what really makes it mysterious is its orbit. It sits more than 650 times farther from its star than Earth does from the Sun. That distance is a major puzzle. Planets usually form in the flat disk of gas and dust that surrounds a young star, but that disk doesn't usually stretch out far enough to form something like HD 106906b. So how did it end up so far away? Some scientists think it might have formed closer in and then got pushed out by interactions with other planets or stars, while others wonder if it came from somewhere else entirely and was captured by the star's gravity. Adding to the mystery, HD 106906b is tilted compared to the star's disk, making its orbit very unusual. It doesn't follow the normal path you'd expect from a planet that formed in a calm, stable system. Instead, it looks like something chaotic happened early in the system's history. Despite its distance, the planet is still glowing from the heat of its formation, which makes it easier to see with powerful telescopes. Scientists are studying its light to learn more about its atmosphere and composition, although so far, HD 106906b is not giving up many answers. The planet's story might even help explain mysteries in our own solar system. Some researchers have compared it to the idea of Planet 9, a proposed planet far beyond Pluto that could explain odd orbits in the outer solar system. If a planet like HD 106906b can exist, maybe Planet 9 can too. TRES-2b is one of the darkest planets ever discovered. It's a gas giant located about 750 light-years away in the Draco constellation. This planet reflects less than 1% of the light that hits it. That's darker than coal, darker than black paint. In fact, it absorbs more light than any known planet. At first, scientists didn't expect a planet to be this dark. Gas giants like Jupiter in our solar system reflect a fair amount of sunlight, but TRES-2b seems to swallow it all. The exact reason is still unclear. It could be due to chemicals in the atmosphere that absorb light, such as vaporized sodium or titanium oxide. Or maybe there are no reflective clouds at all. Even though it's dark, TRES-2b isn't cold. It's another hot Jupiter, orbiting extremely close to its star. A year on TRES-2b lasts just 2.5 days. Because of its tight orbit, the planet is heated to over 1,800 degrees Fahrenheit. That kind of heat makes it glow slightly in infrared, but still, it remains nearly invisible in visible light. Some models suggest the planet's atmosphere might be made of unusual particles that trap heat and light. Others think strong winds might keep any bright clouds from forming. Whatever the cause, it makes TRES-2b stand out as one of the strangest-looking planets in the galaxy. Astronomers discovered TRES-2b using the transit method, where they watch for a small dip in starlight as the planet passes in front of its star. The planet's lack of reflection was a surprise, and it's led to ongoing studies of similar ultra-dark worlds. TRES-2b reminds us that the universe is full of surprises. Planets don't always fit our expectations. Some reflect light like mirrors. Others, like this one, seem to absorb it all. It's a place where night never ends, and we still don't know exactly why. PSR B1620-26b is often called the Methuselah planet, and for good reason. It's one of the oldest known planets in the universe, estimated to be about 12.7 billion years old. That's more than twice the age of Earth, and nearly as old as the universe itself. This ancient planet orbits a strange pair of stars, a white dwarf and a pulsar. Located around 12,400 light-years away in the constellation Scorpius, this planet exists in a place that seems impossible for planets to survive. A pulsar is a rapidly spinning neutron star, the remains of a massive star that exploded in a supernova. It blasts out radiation at incredible speeds. The fact that a planet can orbit a system like this is surprising. The planet is thought to be about 2.5 times the mass of Jupiter and has a wide, slow orbit. A single year on Methuselah lasts nearly a century. What's amazing is how it's managed to stay in orbit for billions of years despite the chaos that usually follows a supernova explosion. Scientists think the planet may have originally formed around a different star and was later captured by this unusual stellar duo. Its age tells us a lot about the early universe. Methuselah formed when heavy elements were still rare. That means rocky planets like Earth hadn't yet become common. Yet somehow, this gas giant formed and survived long enough to be studied today. Astronomers discovered Methuselah using precise timing measurements of the pulsar's signals. As the planet orbits, it creates tiny changes in the pulsar's pulses, allowing researchers to detect its presence indirectly. This was one of the first methods astronomers used to find planets beyond our solar system. Because of its extreme age, PSR B1620-26b gives scientists important clues about how planets first formed in our universe. Back when this planet emerged, conditions were very different. Most stars contained fewer heavy elements like iron, silicon, and carbon, ingredients crucial for building planets. That means Methuselah likely formed in a very metal-poor environment, challenging our understanding of planet formation. Studying Methuselah also helps astronomers understand how planets interact with complex star systems. Its stable, long-term orbit around both a white dwarf and a pulsar provides an example of planetary survival in environments previously thought too hostile. Researchers hope further studies of Methuselah might reveal more about how gravitational interactions can capture planets and hold them for billions of years in such unusual orbits. GJ1214b is about 48 light-years away and is often called a water world. That's because its density and size suggest it may be made mostly of water. It's about 2.7 times the size of Earth and orbits a red dwarf star in the Ophiuchus constellation. This planet doesn't have a solid surface like Earth. Instead, it may have a thick atmosphere and a deep global ocean. The ocean could be hundreds of miles deep, with pressure so intense that water turns into strange forms like hot ice or superfluid, states of matter that don't exist naturally on Earth. GJ1214b is also incredibly hot. It orbits close to its star and has a surface temperature estimated at over 400 degrees Fahrenheit. Even with all that heat, the pressure at the bottom of the ocean might still keep the water in a liquid or exotic state. Scientists have studied the planet's atmosphere using telescopes like Hubble. So far, it appears to have a thick, cloudy atmosphere, which makes it hard to see what's underneath. The clouds could be made of water vapor, or they might contain more complex molecules. We still don't fully understand what the atmosphere is made of. This planet is important because it doesn't fit into the categories we're used to. It's not a gas giant like Jupiter, and it's not a rocky planet like Earth. It might belong to a whole new class of planets called water-rich super-Earths. GJ1214b is particularly interesting because it challenges current scientific models of planet formation. Scientists are curious about how a planet could accumulate so much water during its formation, given that many planet-forming areas around stars are not usually rich enough in ice or water vapor. Understanding GJ1214b could therefore help researchers figure out how water is distributed throughout planetary systems. Future telescopes like the James Webb Space Telescope might give us a closer look at the composition of GJ1214b's atmosphere. With more precise instruments, scientists hope to identify exactly what chemicals or molecules make up those thick clouds. Knowing this could reveal whether the atmosphere could support complex chemical reactions, giving clues about conditions necessary for life. Some researchers even speculate that planets like GJ1214b might have internal heating due to their extreme pressures and gravitational forces. This internal heat could potentially drive deep-sea hydrothermal vents, similar to those found on Earth. If true, these underwater vents might offer energy sources that, on planets in milder conditions, could support simple forms of life. Kepler-16b is one of the most unique planets ever discovered because it orbits two stars. Just like the fictional planet Tatooine from Star Wars, this world would have two sunsets and two sunrises. It's located about 200 light-years away in the constellation Cygnus, and was the first confirmed planet found orbiting a binary star system. The planet itself is a gas giant, about the size of Saturn. It's not likely to support life, but its orbit is incredibly stable. It circles both of its stars every 229 days. The stars themselves are smaller and cooler than our sun, so Kepler 16b is probably quite cold. What's most fascinating is how normal the orbit of Kepler 16b is, despite the complicated gravity from two stars. For a long time, scientists thought that binary stars would make it too chaotic for planets to form or survive, but this discovery proved otherwise. Because it's a gas giant, Kepler 16b isn't likely to have a solid surface, but if it has moons, some of them could be interesting places to study. In theory, those moons could have the right conditions for life, depending on their atmospheres and distances. Kepler 16b changed how scientists think about planet formation. It showed that planets can form and stay stable even in places that seem unstable. The discovery also opened up the possibility of finding other planets in binary or even triple star systems. Seeing a planet orbit two stars isn't just science fiction anymore. Kepler 16b made it real. Thank you for watching this video. If you enjoyed, please leave a like and subscribe and let me know in the comments if you would like to see more videos like this one. Thanks again.